So in the last video, we looked at solving quadratic equations using factoring. And what it came down to was having this ax squared plus bx plus c equals 0. But there's another method that we can use called the square root method, and it particularly works when we don't have b times x. It's like technically b equals 0 in the case. It's just if we just have this x squared term and some constant, we can solve using square roots instead of factoring. So the property that we want to use is that if we have x squared equals some positive number, then what we can do is take the square root of both sides of the equation, and what we'll have is the square root of x squared. It's like the root and the exponent cancel out with each other, so then we'd just be left with x, and that's going to equal the square root of k, but something that always has to follow through is this plus or minus. We end up with two possibilities. So let's see how that works with this first example here. So if I have y squared equals 49, it's like what I'm trying to solve is what can I put in here that'll give us a positive 49? And that's the whole question that square roots ask. So if we take the square root of both sides, the square root of y squared will just leave us with y. And then the square root of 49, when we simplified that before without an equation, we would just use the positive value. It was the principal square root, so we'd have a positive 7 coming through. But in solving an equation, we're looking for all possible solutions, so that changes it a little bit. The idea being that I could have positive 7 squared, and that does give us 49, but something that also works is negative 7 squared. That also equals positive 49. So that's where we end up with that actually we have plus or minus 7. And this notation helps us summarize it into just a single equation, but you could think of this as two separate answers. Y is positive 7, y is negative 7. And in terms of checking our answer, that's kind of what I just showed over there. So what I like to emphasize is anytime you take the square root of both sides, write that plus or minus. Don't forget it, because if you do, it'll leave out a possible solution. So let's look at some more examples here. So what I want to do is I want to get x squared all alone on one side of the equation. So I don't want to take a square root until I do that. So what I'm going to do is add 81 to both sides, which will leave me with 4x squared equals positive 81. And then I'm going to divide both sides by 4. So I have x squared equals 81 over 4. Okay, now that I have x squared all alone on one side of the equation, I can take the square root of both sides. And what I'm going to do is I'm going to write my equal sign, and I'm going to get that plus or minus written down as fast as I can before I forget to do it. So we have our plus or minus. So square root of x squared is just x. And then the square root of 81 over 4, you can use the rule that that's the same thing as square root of 81 over square root of 4. So square root of 81 is 9. Square root of 4 is 2. So this is plus or minus 9/2. And then you could check your answer. We could look at 4 times 9/2 squared minus 81. And does that equal 0? And if we plug that into a calculator, that should all work out. And then same thing 4, and then we have to use those parentheses so that we capture that negative under the square. Minus 81, and does that equal 0? And it sure does. All right, this case here, again, we want to isolate x squared on one side of the equation. So I'm going to divide both sides by 4. So that'll give me x squared equals 25. And then I can square root both sides of the equation, which means I'll have my plus or minus. Square root of x squared is x. Square root of 25 is 5. So x can be positive 5 or negative 5. Okay, one more example here, and with this one, there's a whole expression underneath the exponent of 2. So what I want to do with the square root method here is I want to isolate this t plus 1 squared to one side of the equation. So to do that, I'm going to subtract 9 from both sides. So I'll have negative 5 times t plus 1 squared equals negative 5. Divide by negative 5, divide by negative 5. So then I have this t plus 1 squared equals positive 1. Now I can take the square root of both sides, because essentially I want to cancel out that exponent of 2, and to do that, we use a square root. So I square root both sides. So I have equals, I have plus or minus. On the left-hand side, it's like those cancel out with each other, so all I have left over is t plus 1. On the right-hand side, plus or minus, and then square root of 1 is 1. Now I need another step to solve for t completely, so I need to subtract 1 from both sides of the equation. And what that would look like is I would write this as, and I would actually write this number first. It's better to have the plus or minus in between the values. So I'd write this as negative 1 plus or minus 1. That form's okay, but there's some simplification to do, so you can separate into two solutions here. We would have negative 1 plus 1. We would have negative 1 minus 1. So taking care of that plus or minus is creating two equations. So this first one would tell us that t is equal to 0. And the second one would tell us that t is equal to negative 2. And what we could do is go and plug those in and double check that they work. So that's how we can use the square root method for solving quadratic equations.